Good evening, one and all. In this class, we are discussing one more topic related to organic chemistry. If you like this video, please share to your friends and your well-wishers, and please subscribe. Today we are discussing the topic is conformational isomerism. Conformational isomerism. Yes, this topic is very important topic related to organic chemistry. JEE mains and advanced point of view, conformational isomerism is the most important topic. Today we are discussing the topic is conformational isomerism. Now, what is conformer? What is conformational isomer? Yes, conformational isomerism is the part of stereoisomerism. We know isomerism can be divided into two types, structural and stereo. In structural, we are discussing so many types of isomerism. Now, in stereo isomerism, we are discussing conformational and configurational. Now we are discussing in conformational and configurational. In this video, we are discussing about conformational isomerism. Yes, conformational is isomerism or conformational isomer is the type of stereoisomer. Is the type of stereoisomer in which compounds having the same molecular formula, but different in the rotation of atoms along with the C bond, C single bond C, free rotation of carbon and carbon single bond, free rotation due to free rotation of carbon single bond is called conformational isomerism. We already studied in the configurational, that is geometrical isomerism. In geometrical isomerism, we are discussing between carbon and carbon restricted rotation is observed. Carbon double bond is restricted, not rotated. But here we are discussing conformational isomerism, carbon bond free rotation. Yes, let us clearly explain with an example. Now let us take an example, ethane. This is ethane, CH3 single bond, CH3. Now, this is taken as a carbon. This is taken as a front carbon. There are two carbons are there. Suppose this is the first carbon, this is second carbon. There are two carbons are there. This is the first carbon and this is second carbon. First carbon is taken as a front carbon and the back carbon is taken as a rear carbon. So away from the first carbon. Yes, the first carbon containing atoms are hydrogen and hydrogen. Yes, first carbon containing atoms are hydrogen and hydrogen. This is first carbon. In three-dimensionally, we are represent first carbon, back carbon. Yes, it is possible. Suppose, yes, look at this structure. Yes, there are how many carbons? This yellow color ball is nothing but carbon. Yes, carbon. Yes, towards me, this is the carbon. So therefore, this is taken as a front carbon towards me. In which how many hydrogen atoms are there? Yes, in which how many hydrogen atoms are there? In front carbon, this is one hydrogen, this is another hydrogen, this is another hydrogen. There are three hydrogens are there in front carbon. In front carbon, there are three hydrogens are there. Three-dimensionally, we are represent, this is a front carbon, this is a back carbon. Three-dimensionally, it is represented by ball and stick representation. Ball and stick representation. Three-dimensionally, it is possible. But on the board, how can you represent back carbon? How can you represent on back carbon? Yes. To represent back carbon, it is represented by a circle. A circle. Hence, it is represented as circle like this. Which is a back carbon. Yes, in this back carbon also there are three hydrogens. In front carbon there are three hydrogens. In back carbon also there are three hydrogens. Front carbon containing atoms are three hydrogens. Of course, back carbon also containing atoms are three hydrogens. Yes, we observe this diagram. We observe this diagram. Yes, we observe this diagram. We observe this diagram. In this front carbon, one hydrogen is observed like this. In back carbon, one more hydrogen is there. Yes, if this hydrogen is present, if hydrogen is present here, exactly on the same plane, yes, this is one more hydrogen is there. The back side, that is the same plane, it is the back side of the carbon. Yes, between these two bonds, what is the angle? If you observe like this, what is the angle between these two? 0. Yes, one atom is present behind the another atom. Then how can you represent here? Yes, this is represented behind. One hydrogen is present here, another hydrogen is present behind that. So then you can represent this one. Yes, it is present behind that. So one hydrogen is present like this. Yes, one more hydrogen is there. Yes, one more hydrogen is behind that. Representation. So one hydrogen is present exactly backside of the other hydrogen. Here, that angle between the two bonds is called dihedral angle. Dihedral angle are also called torsional strain. So when the torsional strain angle, dihedral angle is 0. As this conformation is known as, it is a one conformal. This is a one conformal. As this conformation is known as, eclipsed conformation. Eclipsed. If you rotate with an angle 60 degree, if you rotate that compound with an angle 60 degree, yes, this is observed like this. This is observed. This is the first carbon. It's a front carbon, it's a back carbon. Front carbon and a back carbon. If you rotate an angle 60 degrees, yes, this is called free rotation. Yes, free rotation. Carbon single bond is there. Then free rotation is possible. Free rotation is possible. So therefore, if you rotate an angle like this, if you rotate this angle as 60 degree, yes, all atoms are in 60 degree to each other. All atoms. So if you rotate this carbon single bond, free rotation. This is a free rotation. So due to the free rotation of carbon single bond, one atom is migrate with an angle 60 degree. Then you got one more structure. Again, front carbon is represented. That means if you rotate one carbon is fixed. You observe this one. This is a structure in which This left hand side carbon, this yellow color carbon is fixed. This yellow color carbon, front carbon is rotate like this. One carbon is fixed, another carbon is rotated. Or if you fix the front carbon, you rotate back carbon. If you fix the front carbon, you rotate back carbon like this, 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 and so on. There are so many conformers are possible. There are so many conformers are possible for ethane. There are so many conformers are possible for ethane for every angle. Just every angle there is so many conformer. But if you rotate the angle exactly 60 degree, exactly 60 degree, exactly 60 degree, one atom is fixed, another atom is rotated. Yes, this is the front carbon. This is the front carbon. Yes, it containing hydrogen, hydrogen, hydrogen. If you rotate that one with an angle 60 degree with the back carbon, then one hydrogen is observed here, another hydrogen is observed here, another hydrogen is observed here. Yes, what is the angle here? Dihedral angle is 60 degree. This conformation is known as staggered conformation. Staggered conformation. Staggered conformation. So, eclipsed form and staggered form. In these two, which one is more stable? Eclipsed form and staggered form. Which one is more stable? Yes, I can explain with the detailed manner. Yes, we observe here. Eclipsed, ECLIPSCD, eclipsed, staggered, STAGGERED, staggered form. Eclipsed form nothing but angle, dihedral angle is 0. Yes, one atom is behind, exactly behind to another atom, exactly behind. Yes, dihedral angle is 0. If you take with an angle 60 degree, then you got eclipsed form is converted to staggered form. Eclipsed form is converted to staggered form. So eclipsed form is converted to staggered form at dihedral angle. Now the question is, sir, which one is more stable? Which one is more stable? Eclipsed form is stable or staggered form is stable? Yes, look at this one. Yes, one hydrogen is exactly behind the other hydrogen. Here groups are very nearest to each other. Here groups are very nearest to each other. Groups are very nearest. We know this is hydrogen, this is hydrogen. Groups are very nearest here. Groups are very nearest. If the groups are very nearest, then what happens? Between any like groups, that is methyl, or hydrogen, positive charge, like charges or like poles, like atoms, there is a repulsion take place. So therefore, if hydrogen atom is present here, if another hydrogen atom is present here, these groups are very nearest to here. These groups are very nearest to each other. Then there is a repulsion. Repulsion is observed in eclipsed conformer. In eclipsed conformer, there is a repulsion. So, if you rotate an angle 60 degree, yes, what happens? If you rotate an angle 60 degree, what happens? Between this atom and this atom, there is a dihedral angle increases, torsional angle increases between the bond and bond. Okay, between the group and group, the angle is called Van der Waals strain. Between the bond and bond, the strain is called torsional strain. So therefore, this angle is called torsional angle, or simply dihedral angle. So if dihedral angle is rotated by angle 60 degree, so dihedral angle is 60 degrees centigrade. Between groups and groups, there is a repulsion observed, like groups. Always like groups, repulsions are present. But such a type of repulsions is observed in staggered form. Groups are very far to each other. In staggered form, repulsions are less. If repulsions are less, then molecule attains stability. Therefore, which form is more stable? Eclipsed and staggered. Which form is more stable? Yes. In eclipsed form, groups are very nearest to each other. In a staggered form, groups are very far to each other with an angle 60 degree. Therefore, staggered form is more stable. So, we observe stability order. Staggered is more stable than eclipsed. Staggered form is more stable than eclipsed form. The reason is repulsions are less. Yes, same concept is explained with energy diagram. Yes, a graph is drawn between potential energy versus angle of rotation. Angle of rotation. Yes, we take this one at 0 degree. That means eclipsed form. Yes, it possesses certain energy. If you rotate an angle 60 degree, as eclipsed form is converted to staggered. Yes, this is staggered form. So this one is staggered. Suppose this one is staggered. So at 0 degree, it is not the angle of rotation. Angle of rotation. Not dihedral angle. It's very important, not dihedral angle. Angle of rotation. If you rotate an angle 60 degree. So at a 0 degree, the angle of rotation. Suppose this form is staggered form. Then if you rotate 60 degree, it not eclipsed. Again we rotate 60 degree, staggered. Again we rotate 60 degree, eclipsed. Staggered, eclipsed, staggered. Yes. So there is a very important doubt. Sir, which one is taken as a lower energy? Which one is taken as a lower energy? The eclipsed form is taken as a lower energy or staggered form has taken as a lower energy? Which one is taken as lower energy? Suppose if it is staggered, if you rotate 60 degree, eclipsed you got. Suppose if it is eclipsed, if you rotate 60 degree, then it is staggered. Then the problem is, which one possesses lower energy? What is the relation between energy and stability? Yes. For any molecule or any case, lower is the energy, lower is the potential energy, higher is the stability. Lower is the potential energy, higher is the stability. Higher is the energy, lower is the stability. Suppose if you possess more energy, then what happens? Suppose you having more energy, then what happens? You are moving fastly from one place to another place because you have energy. So you having so much energy, so you are moving. You are unstable. So you have energy low. You are not moving fastly from one place to another place. You are sitting in only one place because you have no energy. So if energy is more, activity is more, so then unstable. If energy is less, stability is more. So therefore, we were already discussing in eclipsed and staggered form is more stable because repulsions. That means staggered possess less energy. This is less energy. Yes, this is potential energy diagram. This is less energy. Therefore, this form is eclipsed. This is staggered, eclipsed, and so on. If you rotate 60 angles like this. That means at 0 degree is taken as staggered, then again 120 degrees is staggered. Then again 240 degrees is staggered. Then again 360 degrees is staggered form of ethane. Then there is a doubt. Sir, what is the difference between that energy between eclipsed and staggered? Yes. that energy is nearly 12 kilojoules. The difference between eclipsed form and staggered form energy is 12 kilojoules. 12 kilojoules. Okay. This is about the conformational isomer of ethane. Now we are discussing next conformation of butane. Yes. Our next topic is conformational isomerism of butane. Conformational isomerism of butane. Yes, this is the structure of butane. We know the structure of butane. CH3, single bond, C, H, 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 and CH3. That is the structure of butane. That means we observe this is taken as a front carbon. This is taken as a front carbon. Yes? This one is taken as a front carbon. This is taken as a, suppose it is a front carbon. It is a front carbon. This is back carbon. In front carbon, there are how many groups? In front carbon, there are how many groups? H, H, and CH3. In back carbon also, H, H, and CH3. That means what is the difference between ethane and butane? In ethane, if you take two carbons, each carbon attached with 3 hydrogens. In butane, if you take two carbons, each carbon attached with 2 hydrogens and 1 methyl, each carbon attached with 2 hydrogens and 1 methyl. Yes, look at this structure. Yes, this is the structure of butane. Yes, this yellow color balls nothing but carbons. Yellow color balls nothing but carbons. Yes, in this carbon, this red color ball, this orange color ball is nothing but methyl group. Yes, this carbon also, front carbon also containing methyl group. Yes, look at this structure. Yes, this is carbon, two carbons. Yes, look at this. I put like this. Yes, one carbon is present here towards me, another carbon is away from me. Yes, this is the first carbon, this is the back carbon. Front carbon containing methyl, yes, this is the methyl group, and back carbon containing methyl group. Suppose these two methyl groups are very far from each other. Suppose these two methyl groups are very far to each other. Then between methyl and methyl, van der Waals strain is very less. Between the group and group, van der Waals strain is very less. So repulsions are very less. If you observe like this. Yes. So therefore, it is a front carbon. Let's look at the structure. It is a front carbon. Suppose towards you, this is a front carbon. Towards this phone or computer side, this is front carbon. It contains methyl. It's like this. And 2 hydrogens are there. Yes, this is hydrogen and hydrogen. The back carbon and this one. This is the back carbon. In this carbon, one methyl is exactly look like opposite. But it's not opposite, it looks like opposite. So the back carbon contains methyl group is like this and hydrogen. As here, two methyl groups are repulsions are very less. If repulsions are very less, then molecule attains stability. So therefore, all these structures, all these possible conformers, which has the lowest energy. Yes, this form is the lowest energy and more stability. More stability. Two methyl groups are very far to each other. Yes, this form is called anti form. Anti. Of course, it is staggered. In ethyl structure, hydrogen and hydrogen is very far to each other. That is staggered form. So this is staggered anti form. So then, if you fix it with the front carbon, suppose from your side, this is the front carbon. This is the front carbon. Yes, my left hand, this is the front carbon. This is my right hand, this is a rear carbon. Yes, this one. So in front carbon, methyl is there. In a rear carbon, methyl is exactly opposite to this carbon. Then if you rotate this one, if one carbon is fixed, front carbon is fixed, left hand is fixed, if you rotate this one, as is observed like this. So methyl, one methyl is there, and backside hydrogen is there. Front methyl is there, behind that front methyl, back hydrogen is there. So front methyl is there, back, yes, look like this. Back hydrogen is there, like this. Hydrogen and hydrogen. Yes, what is this form? Yes, this is called eclipsed form. We already introduced ethane. The first form, one hydrogen is behind, another hydrogen is called eclipse. But here very important one, methyl and hydrogen is behind. Hydrogen is behind, methyl is behind. So therefore, this form is called partially eclipsed, not completely eclipsed, partially. So because hydrogen behind, not hydrogen behind methyl. So therefore, this is called partially eclipsed. This form is called partially, not completely, eclipsed. This form. Suppose if you rotate, this is partially eclipsed. Again you rotate, front carbon is fixed. Back carbon is rotated with an angle 60. Yes, like this. Yes, we observe this angle. So from computer, you observe this angle. What is the angle here? Between these two? 60 degree angle is rotated. I observe this structure. Yes, therefore, this form is another name. Here also, methyl and hydrogen is some form, not very nearest to each other. Some form. This form is called Gauche form. Gauchd. Gauche form. Again, if you rotate, so the front carbon fixed and back carbon is in Gauche form. Again you rotate. What happens? Between methyl, dihedral angle is zero. One methyl is the front side and back side also same methyl is there. Same methyl. So dihedral angle is 0. That means methyl behind methyl, hydrogen behind hydrogen. Then this form is called fully eclipsed. Again, if you rotate an angle 60, again we observe that as this form and this form is same. Again, this form and this form is same. This is called Gauche, and this is also Gauche. Again, if you rotate the next one, again, what happens? This methyl is like this methyl, Gauche form. If you rotate, what happens? Partially eclipsed. Yes, next one, and so on, again anti, like that. So if you rotate 60 degree, then what are the forms once again? Yes, first form is anti form. If antiform is taken as a 0 degree angle, if you rotate 60 degree, then partially eclipsed. If you rotate 60 degree, Gachi. If you rotate 60 degree, fully eclipsed. If you rotate 60 degree, Gachi. If you rotate 60 degree, partially eclipsed, and so on. Finally, again antiform. So, in these all conformers, so what are the possible conformers? What are the possible conformers? In ethane, there are two possibilities mainly. One is staggered, another one eclipses. But in butane, what are the possibilities? Anti, Gachi, partially eclipsed, fully eclipsed. Anti, Gachi, partially eclipsed, fully eclipsed. Yes, identify. Identify. Yes, identify. Which one is more stable? Yes. Yes, I think majority members got the idea. Yes, which compound is more stable? Yes. The correct answer is between methyl and methyl, very long distance, the hadron line is very high. So that molecule is more stable. That is anti. Anti-form is more stable than Gachi form, than partially eclipsed, than fully eclipsed. So the least stable is fully eclipsed. Which one is the least stable? Fully eclipsed. The molecule, the conformer, which has least stability, that has more energy profile diagram. Yes. This is the energy diagram between, as we already explained, in the ethane. In y-axis potential energy is taken and x-axis angle of rotation is taken. In the ethane graph, I start with low energy. So graph always not start with low energy. We start with higher energy also. So any case, depending on the molecule. So in first case, between methyl and methyl are in exactly opposite look like. One methyl is there, another methyl is exactly opposite. That form is fully eclipsed. In fully eclipsed, there are two type of repulsions are there. One repulsion between bond and bond. Between bond and bond. Between bond and bond, the repulsion, the strain is called torsional strain. Between group and group, the repulsion is called group and group, or atom and group, or atom and atom. The species, the strain is called van der Waals strain. Due to two type of strains, as this form, fully eclipsed, possess more energy, because repulsions are more, then that attains instability. And repulsions are more, so it attains instability. So repulsions are less. So molecule attains instability. So the molecule is unstable, nothing but energy is more. But here energy is more. Then if you rotate an angle 60 degree, as I already explained, if you rotate an angle 60 degree, what happens? As I already explained, yes, this is the molecule. One methyl is there, another methyl. This is called fully eclipsed. One methyl is exactly up, backside of the other methyl, exactly opposite, exactly opposite, backside. If you rotate an angle 60 degree, what happens? Yes, Gachi form. Gachi form is absurd. Yes, Gachi form has less energy compared to this one. This one, less energy. Again, yes, this is the form. Between, this is hydrogen, this is methyl, this is hydrogen. One atom is behind another atom exactly opposite, like eclipsed. But it is not fully eclipsed, it is called partially eclipsed. Therefore, it possesses again more energy. After that, yes, this is the form. Anti-form repulsions are very less, hence more stability. So they possess very, very low energy. Again anti-form after that, anti-form after that. This is an anti. This is an anti-form. This is an anti-form. Then yes, what happens? Again partially eclipsed. Partially eclipsed means same energy. This is partially eclipsed. This is also partially eclipsed, the same energy. After that, Gachi. Again same energy. After that, Gachi is completely less one. Less one. Say molecule to molecule. That is again fully eclipsed. So now the first compound is fully eclipsed. Second one is Gachi form, partially eclipsed, anti form, partially eclipsed, Gachi form, fully eclipsed. That is the energy order. Yes, I gave the values also here. This is 19 kilojoule. This is 16 kilojoule. This is 3.6 kilojoule. That means between anti-form and fully eclipsed form, what is the energy difference? What is the energy difference? 19 kilojoule. Yes, we are already observed in ethane. What happens? In ethane, eclipsed form, hydrogen repulsions. Trans, that is staggered form. Hydrogen very far to each other are also called staggered form or anti-form. Hydrogen, ethane. Between the eclipsed and staggered, the energy difference is 12 kilojoules. But here, between anti and fully eclipsed, the difference is 19 kilojoules. That means between hydrogen and hydrogen repulsions are there, between the methyl and methyl repulsions are there, that has more repulsions and more energy difference is there. Next one. Between Gachi and partially eclipsed and anti. Yes, this difference is 16. This difference is 3.6. As to observe that all values. Gachi and anti is difference is just 3.6. But anti and partially eclipsed also more repulsions. Yes, is very clear. In ethane, hydrogen repulsions. Only hydrogen repulsions. That is why the difference between staggered and eclipsed is just 12 kilojoules. But in butane, methyl repulsions are there. Methyl repulsions are there. Methyl hydrogen repulsions are there. These two repulsions are more than hydrogen repulsions. In methyl repulsions, more repulsions are there, then more energy difference is there. That is 90. In methyl hydrogen repulsion, it is more than hydrogen repulsion. That is why the difference more than 12, that is 16 kilojoule. But whereas in Gachi, methyl hydrogen not repelled, so very far to each other. So that is why repulsions are less. So stability is more. Comparatively eclipsed, comparative partially eclipsed, Gachi form is more stable, less energy. Of course, when compared to Gachi, anti-form is more stable because so much repulsions are less. Repulsions are very, very less. So stability is more. So finally, we confirm that in these conformers, number 1 and the last one is also 1. So that is fully eclipsed. Fully eclipsed. And then number 2 is partially eclipsed. Number 6 also. So this is this one. This is Gachi. And 2 and 6 are Gachi forms. 2 and 6 both are Gachi forms. Next 3 and this one 5. 3 and 5 are partially eclipsed forms. The last one, 4th one is called anti-form. 4th one is anti-form. So that is the energy order, and energy order is a certain order. The reverse order is stability order. This is about conformational isomerism of butane.